All right, so we're going to use the formal charge to explain the most important Lewis structure. Okay, so if you look at the structure of the Lewis structure of carbon dioxide, you can draw out three Lewis structures. Okay, now you can calculate the formal chart here, so I'm going to keep going, so you don't have to do anymore. So oxygen on the left side, that's -1. Oxygen, carbon in the middle, that's 0. Okay, and oxygen, the triple bond oxygen, that's also +1. So the whole molecule of carbon dioxide is neutral. Now, the Lewis structure of carbon dioxide in the middle, so oxygen, two double bond oxygen, so you got also 0. Carbon in the middle, also 0. And oxygen on the right side, also 0. Okay? And on the right side, the last Lewis structure of carbon dioxide, same thing. So the triple bond oxygen, also +1. Carbon in the middle, 0. And the single bond oxygen, that's -1. Okay, so if you look at the whole thing, you can calculate formal chart, I'm sure. But now, three of these contribute. So put this together, you can explain the structure of carbon dioxide. Right? So each one of them contribute some characteristic to the real structure of carbon dioxide. But actually, not all of them contribute at the same amount. Right? Contribute at the same rate. Only the most important Lewis structure contribute the most, which is this guy. Right. So what do you mean? What do we mean by the most important Lewis structure? Well, this Lewis structure is the most stable. So minimize formal charge. So the one that doesn't have charge is the most stable, and this guy gonna be the most important, or the contribute to the real structure of carbon dioxide the most. Okay. And what I'm saying is the real carbon dioxide look more like this guy than the other. Right. So experimentally, we find out that the bond of the CO bond in carbon dioxide, of course, they are the same, both bonds are the same, and the bond length is similar to the bond length of C double bond O, not single bond or not triple bond. Okay, so almost double bond basically. All right, so this guy contributes to the real structure of carbon dioxide the most. This is the most important Lewis structure. Right? And how do you know which one is the most important Lewis structure if they are multiples? Well, the one that's more stable. Usually the one that's stable is the one that have the lowest formal charge to combine the total. Right? So this is neutral. This is called -1, +1, +1, -1. The neutrals wins, basically. All right. So phosgene, you can draw two Lewis structure of phosgene. Right? So I'm going to ask you just like straight away. Between two resonance structures of phosgene, which one is the most important Lewis structures? Okay, how do you know? Well, let's calculate formal charge. Right? So chlorine, start chlorine on the left side right here. Group 7, so 6 dot, 1 line, total of 0. Okay, carbon in the middle, so group 4, so 4 minus no dots, 0, so 4 lines, total of 0 as well. Oxygen at the top. So what's got? So 6 carbon, 6 electrons, 4 dots, 2 lines, total of 0. Right? Chlorine on the right, so same thing. So you can see that the single bond chlorine, they have the same formal charge right there. So it's also 0. All right. Now next one, chlorine, again still single bond chlorine, so the formal charge is the same thing, 0. Okay. Carbon in the middle, so still 4 bonded carbon, so also same thing, so also 0, neutral. Oxygen at the top. We're going to do it. We don't have it yet. So, all right, now 6 electrons. How many dots? 6 dots. How many lines? 1 line. Total of -1. This guy -1. And chlorine, double bond chlorine. So double bond chlorine. So group 7 valence electron. 4 dots. 2 lines. Total of +1. Okay. So who's the most important Lewis structure? This guy, the more stable one, is the more important Lewis structure. Okay, so we're comparing neutral phosgene versus charged phosgene. The neutral one, of course, is more stable. So the real structure of phosgene will look more like the neutral one, the neutral phosgene. Have some just small characteristic of the charged phosgene. Okay, all right. I would like to add take a pause right here, talk about our new the segment that we talked about before. So, well, that took a turn. Let's see the conversation between two people. Okay, this one a girl talked to her mom. So, and she said, I got an A in chemistry. And the mom said, WTF, well done. Mom, what do you think WTF means? Well, that's fantastic. Okay, smart mom. Next one. Talk to the dad. Dad, what? Want some up dog for dinner? What? I don't know what up dog is. Anyone here knows? I don't know what up dog is. Like, if you can email me. I try to Google it and I don't really get anything. If you know, maybe a slang or something. What's up dog? The dad said, what? Do you want up dog for dinner? And dad said, what's up dog? Not much. You? Sometimes I wish you would act like you are almost 18. Oh, that's kind of cool. All right, let's go to the next.